Now, how does this all work? Key distribution is kind of a two-step process. The first step is to generate a raw key that has correlation between Alice and Bob. This is where the quantum physics comes in. Alice and Bob can either use quantum entanglement or quantum communication to produce these correlated random bit strings or raw keys. Once those raw keys have been established, Alice and Bob then use classical processing and communication over a public channel to reduce those correlated bit strings into equivalent bit strings that are not only identical, but are secret from any eavesdroppers. And this requires a couple steps, such as eavesdropper detection, error correction, key sifting, and privacy amplification. And we'll tell you all about each of the steps later in this talk. Now, for key distribution to be secure and to work, there's a few assumptions that must fall in place. First, Alice and Bob must be able to authenticate each other over the public classical channel. Alice must know that they are talking to Bob and receiving messages from Bob, and vice versa. Second, the hardware and software that Alice and Bob use must be characterized and trustworthy. Since these hardware devices and software have access to the secret keys that Alice and Bob are creating, we need to make sure that that software or hardware is not sending those keys to an adversary. Third, Alice and Bob's randomness that they use to produce these keys must be private to themselves and uniformly distributed. If an eavesdropper knows the random numbers that are being generated by Alice to produce the raw key, then that breaks the security of this protocol.